Correcting electrical grounds in computer equipment is crucial for several reasons. Firstly, electrical safety is paramount. Proper grounding prevents electrical shock hazards and protects against electrical fires. Secondly, equipment protection is enhanced. Poor grounds can lead to overvoltages and electrical noise, which can damage computer equipment and shorten its lifespan. Thirdly, grounds provide a low resistance path for electrical currents, preventing electromagnetic interference or EMI from disrupting equipment performance. Inadequate grounds can cause electrical noise to accumulate on the ground plane, which can lead to image and computer lockups. Electrical noise caused by poor grounds can corrupt data and cause data loss. Proper grounding ensures that electrical signals have a clear path to travel, resulting in improved equipment performance and reliability. Adequate grounds help meet electromagnetic compatibility or EMC regulations by reducing electromagnetic emissions and preventing interference with other electronic devices. Many electrical codes and standards require proper grounding for the safe and reliable operation of electrical equipment. When explaining the importance of correcting electrical grounds to customers, it's helpful to emphasize the importance of electrical safety. Explain that poor grounds can pose a risk to personnel and equipment. Highlight the potential damage to equipment because poor grounds can lead to costly repairs or even equipment failure. Explain the impact on performance, noting that inadequate grounds can cause intermittent problems such as image lockups or data corruption. Providing evidence is effective. Show customers how correcting electrical grounds has resolved similar issues in the past. It's also helpful to emphasize long-term benefits because proper grounding extends the lifespan and reliability of computer equipment, ultimately saving money. Understanding the fundamental principles behind grounding will help you communicate its importance effectively. Grounding provides a path for fault current to return to the source, allowing overcurrent protection devices such as circuit breakers or fuses to operate and clear the fault. Without a proper ground, fault current may find unintended paths through equipment or personnel, posing a significant safety risk. The ground itself is typically connected to a grounding electrode system such as a ground rod or a metallic water pipe, which provides a connection to the earth. This connection to earth helps to stabilize voltage and provides a reference point for electrical systems. Different types of grounding systems are used in various applications. A common type is equipment grounding, which connects the non-current carrying metal parts of equipment to ground. This helps to prevent electrical shock if a fault occurs within the equipment. Another type is system grounding, which grounds the neutral point of a power system, such as a transformer or generator. This helps to stabilize the voltage and reduce the risk of overvoltages. When troubleshooting grounding issues, it's important to use appropriate test equipment, such as a ground resistance tester or a multimeter. A ground resistance tester measures the resistance of the grounding electrode system, which should be within acceptable limits specified by electrical codes and standards. A multimeter can be used to check for voltage between ground and other conductive surfaces, such as equipment enclosures or metal pipes. Any significant voltage indicates a potential grounding problem. Visual inspection is also important. Look for loose or corroded connections, damaged grounding conductors, and improper grounding practices. Pay attention to areas where equipment is frequently moved or where there is exposure to moisture or chemicals. Common grounding problems include high ground resistance, open ground conductors, and ground loops. High ground resistance can be caused by poor soil conditions, corroded electrodes, or loose connections. Open ground conductors can be caused by damaged wires or loose connections. Ground loops occur when there are multiple ground paths, which can create circulating currents and electrical noise. Correcting grounding problems often involves cleaning and tightening connections, replacing damaged conductors, and installing additional grounding electrodes. In some cases, it may be necessary to redesign the grounding system to ensure adequate performance. When working on electrical systems, it's important to follow all applicable safety precautions, including wearing appropriate personal protective equipment such as insulated gloves and safety glasses. Always de-energize equipment before working on it, and use a qualified electrician for any work that you are not comfortable performing yourself. Regularly inspect and test grounding systems to ensure they are functioning properly. This can help to prevent electrical shock hazards, protect equipment from damage, and ensure reliable operation of electrical systems. By understanding the principles of grounding and following proper installation and maintenance practices, you can create a safe and reliable electrical environment. Remember that grounding is not just a matter of meeting code requirements, it is a fundamental safety practice that protects people and equipment from electrical hazards. In addition to the points already discussed, there are some specific issues that can arise in computer equipment due to poor grounding. One common problem is electrostatic discharge, or ESD. ESD can occur when there is a buildup of static electricity on a person or object, which then discharges to a nearby object. This can damage sensitive electronic components in computer equipment. Proper grounding helps to dissipate static electricity and reduce the risk of ESD damage. Another issue is common mode noise. Common mode noise is a type of electrical noise that is present on both the signal and ground conductors of a circuit. This can cause problems with data transmission and can lead to errors or data loss. Proper grounding helps to reduce common mode noise by providing a low impedance path for the noise current to return to the source. Furthermore, transient voltage surges can also cause problems. Transient voltage surges, such as those caused by lightning or switching events, can damage computer equipment. Proper grounding helps to divert transient voltage surges away from sensitive electronic components. To effectively address grounding issues, it is important to understand the different types of grounding conductors. The grounding electrode conductor connects the grounding electrode to the equipment grounding system. The equipment grounding conductor connects the non-current carrying metal parts of equipment to the grounding electrode system. The bonding jumper connects different parts of the equipment grounding system together. All of these conductors must be properly sized and installed to ensure effective grounding. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding. It specifies the minimum size of grounding conductors, the methods for installing grounding electrodes, and the requirements for bonding different parts of the electrical system together. Consulting the NEC and other applicable standards is essential when designing and installing grounding systems. When troubleshooting grounding problems, it is important to use a systematic approach. Firstly, gather information about the problem, such as the symptoms, the location of the equipment, and the history of the electrical system. Secondly, perform a visual inspection of the grounding system, looking for loose connections, damaged conductors, and improper grounding practices. Thirdly, use test equipment to measure ground resistance and check for voltage between ground and other conductive surfaces. Fourthly, analyze the data and identify the root cause of the problem. Fifthly, implement corrective actions, such as cleaning and tightening connections, replacing damaged conductors, or installing additional grounding electrodes. Finally, verify that the problem has been resolved and document the findings. In addition to these technical aspects, it is also important to communicate effectively with customers about grounding issues. Explain the importance of grounding in simple terms, avoiding technical jargon. Use visual aids, such as diagrams or photos, to illustrate the concepts. Be patient and answer questions thoroughly. By building trust and rapport with customers, you can increase their understanding and cooperation in addressing grounding problems. Maintaining a well-grounded electrical system is an ongoing process. Regularly inspect and test grounding systems to ensure they are functioning properly. Keep connections clean and tight. Repair any damage promptly. By taking these steps, you can ensure the safety and reliability of electrical systems and prevent costly downtime and equipment damage. Remember that grounding is not a one-time fix. It is an essential part of a comprehensive electrical maintenance program. In complex systems, consider using specialized grounding techniques such as isolated grounds or dedicated grounding conductors for sensitive equipment. These techniques can help to further reduce electrical noise and improve performance. Isolated grounds provide a separate grounding path for sensitive equipment, preventing noise from other equipment from interfering with its operation. Dedicated grounding conductors provide a low impedance path for ground current, reducing the risk of voltage drops and electrical noise. Surge protective devices, or SPDs, can also be used to protect equipment from transient voltage surges. SPD are installed in parallel with the equipment they are protecting and divert surge current to ground. SPD should be properly grounded to ensure they function effectively. When working on grounding systems, it is important to be aware of the potential hazards involved. Electrical shock is a serious risk, so always de-energize equipment before working on it. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable safety procedures and regulations. If you are not comfortable working on electrical systems, consult a qualified electrician. Grounding is a critical aspect of electrical safety and performance. By understanding the principles of grounding, following proper installation and maintenance practices, and communicating effectively with customers, you can create a safe and reliable electrical environment. Consider the specific environment where the equipment is located. For example, in areas with high levels of moisture or corrosive chemicals, it may be necessary to use special grounding electrodes or conductors that are resistant to corrosion. In areas with high levels of lightning activity, it may be necessary to install additional lightning protection measures. When working on existing grounding systems, it is important to document any changes or modifications that are made. This documentation should include a description of the work performed, the date of the work, and the name of the person who performed the work. This documentation can be helpful for future troubleshooting and maintenance. Regularly review grounding practices and procedures to ensure they are up to date and effective. Stay informed about changes in electrical codes and standards. Attend training courses and seminars to improve your knowledge and skills. By continuously learning and improving, you can provide the best possible service to your customers. Grounding is not just a technical issue, it is also a matter of professional responsibility. As a senior engineer, you have a duty to ensure the safety and reliability of electrical systems. By taking grounding seriously and by educating your customers about its importance, you can make a positive impact on their operations and their bottom line. In addition to the topics discussed, consider the role of grounding in specific types of equipment. For example, in medical equipment, grounding is critical for patient safety. In telecommunications equipment, grounding is essential for preventing interference and ensuring reliable communication. In industrial equipment, grounding is necessary for protecting workers and preventing equipment damage. Each type of equipment may have its own specific grounding requirements. When working with sensitive electronic equipment, it is important to use proper grounding techniques to minimize electrical noise. Shielded cables, filters, and other noise reduction devices can also be used to improve performance. In some cases, it may be necessary to use a combination of grounding and noise reduction techniques to achieve the desired results. Grounding is a complex and multifaceted topic. By continually expanding your knowledge and skills, you can become an expert in this field and provide valuable service to your customers. Remember that grounding is not just about meeting code requirements, it is about protecting people and equipment from electrical hazards and ensuring the reliable operation of electrical systems. Poor grounding is often the result of shortcuts taken during installation or maintenance. Emphasize the importance of following proper procedures and using quality materials. Explain that cutting corners on grounding can lead to serious consequences. Encourage customers to invest in proper grounding and to maintain their grounding systems regularly. Grounding is an investment in safety and reliability. By promoting this message, you can help customers understand the value of proper grounding and make informed decisions about their electrical systems. Also explain that simply adding ground rods does not guarantee a proper ground. A ground resistance test is necessary to ensure the ground is sufficient. Depending on local code, ground resistance must be below a certain number of ohms, often 25 ohms or less. If the resistance is too high, additional ground rods or other measures may be needed. Furthermore, the placement of ground rods is important. They should be spaced at least the length of the rod apart to be effective. Avoid placing them near underground utilities or other metallic structures that could interfere with their performance. Using a ground grid can improve grounding in large facilities. A ground grid is a network of interconnected ground conductors buried in the earth. This provides a low impedance path to ground for a wide area. It is often used in substations, power plants, and other large industrial facilities. Proper bonding is essential for effective grounding. Bonding ensures that all metal parts of the electrical system are connected together to form a common ground. This helps to prevent voltage differences between different parts of the system, which could cause electrical shock or equipment damage. Bonding jumpers should be properly sized and installed according to code requirements. In some cases, it may be necessary to use exothermic welding to create a permanent and reliable bond. Exothermic welding creates a molecular bond between two metal parts, which is stronger and more resistant to corrosion than mechanical connections. When inspecting grounding systems, pay attention to the condition of ground clamps. Ground clamps are used to connect grounding conductors to ground rods, metal pipes, and other grounding electrodes. They should be made of corrosion-resistant material and properly tightened to ensure a good connection. Replace any clamps that are corroded or damaged. Also, be aware of the potential for stray currents in grounding systems. Stray currents can be caused by unbalanced loads, harmonics, or other electrical problems. They can cause corrosion of grounding conductors and other metallic structures. Use appropriate measures to mitigate stray currents, such as balancing loads, installing harmonic filters, or isolating sensitive equipment. Consider the impact of grounding on communications systems. Ground loops can cause interference in communications systems, leading to poor performance or data loss. Use proper grounding techniques to minimize ground loops and ensure reliable communications. Fiber optic cables are often used to isolate communications equipment from grounding problems. Fiber optic cables are non-conductive and do not create a ground loop. When working on grounding systems, be aware of the potential for underground utilities. Always call before you dig to avoid damaging underground pipes or cables. Damaging underground utilities can be dangerous and can cause service disruptions. If you are working near underground utilities, use hand digging techniques to avoid damaging them. By following these additional guidelines, you can further improve your understanding and implementation of grounding practices. Remember that grounding is a continuous process that requires ongoing attention and maintenance. Stay vigilant and proactively address any grounding issues that arise.